Why I chose mechanical engineering as my major in college. I'm just gonna share my experience on this. What is mechanical engineering? If you Google it, the basic definition you're gonna get is
we're gonna take on the world.
What's going on, YouTube? Welcome back to my channel. On this video I wanted to take some time to talk about why I chose mechanical engineering as my major in college, and what are some of the pros and cons from my own experience, in case some of you may have any questions or wondering whether or not this is a good major for you. So I just gonna share my experience on this, and you let me know what you think about it. And if you have questions, make sure you share it, you ask in the comment section. And if you're not already subscribed, I hope you're gonna go ahead and do so after this video, or during this video, or actually right now. Let's get it started. Let's go back to just do a little bit of a background on what is mechanical engineering, right? So if you Google it, the basic definition you're gonna get is it's a branch of engineering that combines engineering, physics, and mathematics with the material sciences to design, analyze, manufacture, and maintain mechanical systems. They say that it's one of the oldest and widest engineering branches, which, from my knowledge, this is the case. However, I don't really think this basic definition really tells everything about it. You know, mechanical engineering is one of those things where you can't really define it in one or two sentences, but it really does combine a lot of engineering, physics, and mathematics, right, principles, and then you use that, and then you combine with the other sciences, material sciences. Depending on your industry, you're going to be combining a lot of different fields of study to kind of be able to do what you do, right? So if you're in the aerospace or aviation industry, you might be combining engineering, physics, and mathematics with a lot of fluid dynamics and the understanding of how fluid flows. In this case, aviation is, you're gonna probably just talk about or think about air, right? So, but air is a fluid. So you know how the plane or the item that you're designing or a drone is going to interact with the fluid around it, right? If you in somewhere where it's making microchips, you're gonna think about more about mechanics of materials. You know how those composite materials, small composite materials, are going to be interacting, or how they're going to be reacting to electricity, to all the other components in your in the computer or the machine that you're making. It is the application. It's a field of engineering that combines the physics and the mathematics principles to design, analyze, manufacture, and maintain mechanical systems. One of the things that attracted me to mechanical engineering was the fact that the options are limitless. The options that you have, the things that you can do, the industries that you are able to work in are limitless. When coming out of high school, I didn't really know what I wanted to do. So, you know, when I considered engineering as just engineering discipline, I felt like I looked at all my options, and I felt like, hey, mechanical engineering allows me to kind of touch on so many other fields of engineering that I could always pivot, you know, or gravitate myself towards something that I felt like I'm more passionate about, because I didn't really know what I was passionate about while in college. So I didn't pick mechanical engineering because of that, because it gave me options. From my experience and my observation, there are different, depending on the industry that you're working in, right? There are different things that you can do, right? So what do I mean? Just because two people are mechanical engineer and they work in the same company, it doesn't mean that they do the same stuff, You know, two people can be working together with both mechanical engineering degrees and they don't do the same stuff, right? If you think about the engineering discipline itself is like a whole, it's an entire ecosystem, right? So you have, and it's an entire ecosystem, and from each end of the spectrum, depending which end of the spectrum you're on or you're looking at, there will be engineers needed there. So if your interest is in designing things, right, using AutoCAD or SolidWorks, making 2D or 3D designs and kind of conceptualizing and visualizing, taking ideas from your mind into paper, sketch, doing that kind of stuff, right? So that's usually where the work begins, right? So first you kind of have a concept, and then you design it, and then you look at it, make calculations and see if it's actually realistically possible theoretically, or using computers to determine if it's theoretically possible, right? So there's that. You can work in that environment if you do not like to interact with a lot of people and you just like to do your work and work work solo and do what you gotta do and get going. You're not a very social person. There is that option to work in the design field depending on any industry. Again, this is not the video about like the industries. It's limitless. Think about everything, like from oil production to airplane manufacturing, or the making of airplanes, to making of satellite spaceships. Everything, food production, shipping, transportation, construction, technology, like all of these industries, and all of these are going to require, within some level or another, they're going to require some little bit of any of these work environments that I'm listing out. So I just talked about the design phase. So what's the next one? Working in the prototype building aspect. So let's say, once something is designed and it's the first time it's being designed, right? You need to test it out and see if it actually comes out physically as it was planned, right? And this is where the rubber meets the road again for the first time, where you are trying to take it out. So here you may be interacting with people who are strictly design mechanical engineers who are strictly just designing things, right? And you may be interacting with machines that maybe do 3D printing, if that's the case, or you may be outsourcing that, and you will be working with other companies that probably also have mechanical engineers specialized in printing these parts and then sending them back to you, and then you work in the process of putting it together and then doing the testing for it, right? So there's that aspect of it. And then you have the production aspect of it, or you can also think about this as the manufacturing environment. So once a product has been designed, it's been prototyped and tested and approved, right? Then there's always going to be the mass production requirement of it. That's the manufacturing aspect of it. This aspect also of a product will require engineers. So in this case, you would be just more so focused on the machines and the plant that produces all the systems that makes these products or a product, and make sure that from a quality point of not just from a quality point of view, but make sure that the production quota that you guys need from a business point of view is being met on a regular basis. If you notice any bottlenecks, if you notice things that are delaying production, or noticing things that are affecting production, just engineering your way into solving that problem, right? Or maybe there's a supply chain issue, right? Possibly, is it possible that you can maybe just switch out one part to another brand that does the same, that meets the same requirements, but is just a lot more available, readily and easily accessible. So just engineering that, right? That's the production aspect or manufacturing aspect of things. And then what else do I have here? Then I have the quality aspect of things, right? So quality goes hand in hand with production, because you want to make sure that if you're producing thousands and thousands of parts, you want to make sure they're coming out right, because if not, that's going to cost a lot of money to the company, and it's going to cause delays also to your clients. So quality plays a role in making sure that the products are being built right as they per the design, and make sure that there aren't any defects in the products themselves, right? So just testing that and making sure that before a product goes out of a plant or is sent to a customer, that it's doing what it's supposed to do. So you could also be on this side of things, right? So what are some common mechanical engineering roles that you will see oftentimes in job descriptions or job titles, right? So you'll see stuff like design engineer, right? So design engineers it's very self-explanatory, right? Or you can see something like, design engineer, or technical engineer, or senior design engineer, right? All of that kind of falls within the same category, just depending on your level of experience. There's that. There's application engineers. Application engineer oftentimes they do some design, but they also interact with the customer. Usually these are companies that have a product, but that requires tweaking every now and then to meet every customer's needs, because it varies slightly, right? So for example, your company may make a small an item that, for example, is made with carbon steel, and it works well right within the United States, this built as is. But a company may be in Antarctica, and then they may be like, hey, they may be operating in Antarctica, and they're ordering products for something in Antarctica. And you have to be the one as an application engineer to look at the application, basically where the product is going to be applied, and use your judgment and your engineering understanding of how materials work under different extreme conditions, to make sure that if there are any adjustments that need to be made, you can do that. So for example, in that case, right, carbon steel is very brittle, right? The when you put it under certain temperatures, as the temperatures drop below zero, right, it becomes less and less effective and becomes very brittle and easy to break. So if this item was designed to be flexible every now and then, depending on the environment, and you take it somewhere like Antarctica as is, it's not going to work. So as an application engineer, it would be your job to say, hey, maybe we need to carbon steel, the standard carbon steel that we have is not going to work here. Or maybe we need to use another grade of steel, right? Or maybe we can use stainless steel, or some kind of other material, right? Or maybe you can design that item with rubber pieces that are just as effective, if not, or even if less effective, at least they meet the minimal requirements of the operations of the environmental conditions, right? The same thing, if this is operating at sea level and steel again gets corroded, right? You may need to be coating it with some kind of anti-corrosive item, right? So as an application engineer, it would be your job to kind of think about all of these things as you examine a client's request, right? So technical or design engineering, you get application engineering, you have product engineer. Product engineer also is another term for something that requires a lot of design. Then you have project engineer. Project engineers also is another one over there you're going to see a lot. Project engineer usually involves many aspects of this. So it may be project engineers usually dabble in all of these things, depending on just which stage of a design or of production they're in, which stage of a project a company may be in. So project engineers may be doing a lot of this. Sometimes they do the coordination between departments or branches of the same company, right? You have the electrical engineers designing a certain aspect, you have mechanical engineer doing another aspect. So the project engineer is the one that kind of looks everything together, also similar to sometimes a systems engineer, and they kind of examine all of that. Beyond that, there's always the option to be like go up as become a technical manager. Also, that's also an option that is always there for people who have that after they have the experience and they're looking into leading people. Or you can stay just a technical person and working individually and just managing yourself and working as part of a team. So both career tracks are rewarding. Again, in any industry that you're going to be working on, these are probably the positions that you might find yourself in, and some of these are inclusive of each other. Like somewhat depending, every company is a little bit different also, so you should kind of clarify, if you're interviewing for a position or interested in a position, you should kind of clarify with them and ask to see, hey, what are the expectations for this role, right? And then you kind of are able to compare that to you. Again, if you're someone who's just coming out of high school or still in college and you're thinking about this, like I said, it's mechanical engineering is very broad, but it gives you many options, right? So just think about what industries you're interested in, right? And within those industries, what do you like to do? Do you like working with people? Do you like working by yourself solo? Do you prefer leading projects, right? Being the one that kind of looks at everything together and kind of makes sure all the pieces fit together, right? Do you want to be that person who puts the puzzle together, or do you want to be just part of a team that just makes each part of the puzzle piece? Every each aspect is as important. I'm not gonna say one is more important than the other, but I know, for example, for myself, I more so prefer to be involved in that role of putting the puzzle together because, I like to think holistically and look at everything from a broad point of view and then also look into the details, right? Whereas I've worked with people, I've also studied while in college, I've studied and been on projects with people who prefer working just solo. Like they don't want to deal with having to manage other people and the stress of dealing with other people and stuff like that, right? And when as a professional, I've also dealt with both. There are engineers who like to work with other people. There are engineers who do not, who like to just worry about taking care of themselves and just working as part of a team instead of leading a team, right? So I hope this was beneficial. I hope this is helpful for you as you think about, as you consider mechanical engineering. Now, I don't know if other industries or other disciplines of engineering like electrical gives you this many options and this many places where you can insert yourself into, and be a productive member of society. Maybe the case if you've worked in other ones, just comment in the description. Comment, leave your thoughts in the comment section and just what you think about it. By now, you should know, if you're watching this, you should know that I do have a podcast dedicated just for engineers. It's called the Engineers Hub Podcast, and I actually bring on their engineers from across all backgrounds, all majors: mechanical, electrical, computer, agricultural, structural, aeronautical, chemical, just manufacturing, just whatever you can think of, right? So if I haven't yet, once I get to it, probably I will be able to, or once I come across someone within that discipline, I'll be able to. Check it out. Check out the podcast and listen to the episodes if you're doing your own research and see what interests you. And as you listen to people, also look at their personalities and like whether or not, if they enjoy what they do, what part of their personality makes that enjoyable, right? And compare that to you and what you enjoy doing also as you make these decisions and make these thoughts. I hope you enjoy this video, and share, like, and subscribe to the channel. Highly appreciate it. See you on the next one.